Tonight's lesson is unit rate as the constant of proportionality. So my hope is that tonight, by the end of the lesson, you will solidify in your mind that when I ask you for the constant of proportionality, all I'm actually asking you about is the unit rate. You're going to be able to analyze proportional relationships to identify the constant of proportionality. The constant of proportionality is the value that describes the multiplicative relationship between two quantities x and y. If you can get y by multiplying each x by 3, 3 is your constant of proportionality. It's the same value as the unit rate. Let's look at an example we've looked at earlier in this unit. I'm guessing this might be rice, so we want to know, is weight proportional to cost? So if I buy 2 pounds of rice, what would I multiply that 2 by to get my cost of 6? If I buy 4 pounds of rice, 4 times what is 12? And if I buy 6 pounds of rice, 6 times what is 18? If there is a constant number that we can multiply by every time, we're looking for the multiplicative relationship. So if we can find a constant number that we multiply by every time, that constant will be our constant of proportionality. 2 times what is 6? 2 times 3 is 6. 4 times what is 12? 4 times 3 is 12. 6 times what is 18? 6 times 3 is 18. Because every time we multiply by this constant of 3, 3 is called our constant of proportionality. And we've actually worked with this several times, even though I haven't used this exact verbiage. Every time we figured out if a table of values was proportional, if the quantities within the table were proportional, we figured out what we could multiply by every time. We were finding the constant of proportionality every time. And all that constant of proportionality means is $3 per pound of rice. Every time you buy another pound of rice, you're going to pay another $3. So that's our unit rate also. If you know your unit rate for milk, statewide milk average is $3 per gallon, well, our constant of proportionality is also 3 because you're paying $3 for the first gallon, $3 for the next gallon, $3 for the gallon after that. Let's say you wanted to know for 8 gallons, how much would you pay? You would take that 8 and multiply by 3. If you wanted to know for 12 gallons how much you would pay, you would take 12 and multiply by 3 because 3 is our constant of proportionality or our unit rate. Let's take a look at this first example. It says you need what? Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needed 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needed the cookies for an event at school on the very next day. Brandon and his mother determined they can fit 36 cookies on 2 cookie sheets. Brandon's mother is quite patient because many moms would be sad if you came home and said, I need many, many cookies and I need them homemade and I need them for tomorrow. But Brandon's mother regrouped and she's working this out with him. What I need you to figure out is the number of cookies proportional to the number of sheets used in baking? You're going to create a table of value that shows data for the number of sheets needed for the total number of cookies needed. And I started this out for you. I started 2 cookie sheets is how many cookies, 4 cookie sheets is how many cookies, 6 cookie sheets is how many cookies. And in that last row, I'm going to be looking for the totals. How many cookie sheets do you need total? How many cookies will that be total? So I need for you to pause the video, try this out, and come on back. All right. Well, we know that they determined they could fit 36 cookies on 2 cookie sheets. So if I have 2 cookie sheets, I can fit 36 cookies on those. If I want to know my unit rate for this, or my constant of proportionality, I would take my number of cookies, 36, and I divide by my number of cookie sheets needed for those 36 cookies. 2 cookie sheets. 36 divided by 2. Use your calculator if you need. That'll give you 18 cookies per sheet. And that's your constant of proportionality. Here, what that says is we can do 2 times 18 to get us 36. So that's going to be our constant of proportionality. So there's many ways to go about this, but one thing I could quickly do now, if I know it's 18 cookies per sheet, I have 4 cookie sheets. I can do 4 times 18, which is 72. Use your calculator if you need. I can do 6 times 18, which is 108. Again, use your calculator if you need. And if you want to verify, you can always do 72 divided by 4. You're going to find 18 cookies per sheet. 108 divided by 18 is going to, 108 divided by 6. Your number of cookies over your number of sheets will be 18 cookies per sheet. Finally, I need to know about the totals. So for each of those 96 students, they each get 3 cookies. So 3 cookies for the first student, 3 cookies for the next student, 3 cookies for the student after that. You can just take 96 times 3. Use your calculator if you need. And that will give you 288 cookies that Brandon and his mother need to make that afternoon. And I know, to know how many sheets I need, I know the number of sheets times 18 will get me to 288. Another way I could work it out is I could take my total number of cookies, 288, I could say divide it by what gets me to my 18 cookies per sheet. We can use a ratio if we want. So I know it's 18 cookies for one sheet. I also know we need a total of 288 cookies. So the question is, how many sheets? And here I would be doing 18 times what is 288. Once I know that value, I'll multiply top and bottom by that same value. If you're not sure 18 times what is 288, which I don't know, I can easily divide out 288 divided by 18. Use your calculator if you need to. 88 divided by 18, you're going to find that that is 16. So 1 times 16 is 16 sheets. So you'll need 16 sheets of cookies if you want to be able to produce 288 cookies total. Is this proportional? Of course this relationship is proportional, and here's why. You can always take your number of cookies on a sheet, so your number of sheets of cookies times 18 cookies per sheet every time will get you your total number of cookies. And because there is that constant value we can multiply by every time, you're guaranteed it's proportional. Okay. Right now, I'd like you to try to name the unit rate. I'd like you to name the constant proportionality and describe what it means. We actually discussed both of those on the last sheet, so hopefully those should be pretty quick. And then finally, it took 2 hours to bake 8 sheets of cookies. If Brandon and his mother begin baking at 4 p.m., when will they finish baking the cookies? So take a minute, pause the video, try it out, come on back. So the unit rate we've talked about, that unit rate is 18. That means 18 cookies per sheet. And what's the constant proportionality? Well, that's still 18. That's still 18. Every single time here, we multiply by a constant value of 18 to get from our number of sheets to our number of cookies. So again, the 18 means 18 cookies, 18 cookies per sheet, per one cookie sheet, if you want to put that 1 in there for you. Finally, it took 2 hours to bake 8 sheets of cookies. It took 2 hours to bake 8 sheets. If Brandon and his mother begin baking at 4 p.m., when will they finish? Well, we know to get the total of 288 cookies, they need to bake 16 sheets. So we know we need to bake 16 sheets. So here we can simply go 8 times what is 16? Well, 8 times 2 is 16. If you're going to multiply the denominator by 2, you multiply the numerator by 2. 2 times 2 is 4. It must take them 4 hours to bake those 16 sheets. Take a look at another example. Suzette and Margot want to prepare crepes for all the students in their French class. A recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. The girls know they already have plenty of flour and milk, but they need to determine the number of eggs needed to make 50 crepes because they are not sure they have enough eggs to make the recipe. Consider the amount of eggs necessary to make crepes. What is the constant proportionality? What does the constant proportionality mean in the context of this problem, and how many eggs will be needed for 50 crepes? I need for you to pause the video, try it out, come on back. All right, hopefully you paused the video. So I know from my recipe, 20 crepes call for 2 eggs. So I know I have 20 crepes need 2 eggs. I could divide this out to get my constant proportionality or my unit rate. Divide denominator and numerator by 2 because we want to know how much per 1. So how many crepes can I make per 1 egg? 20 divided by 2, that's 10 crepes for 1 egg. So what does the constant proportionality mean in the context of this problem? So our constant proportionality is 10 or 10 over 1, and it means you can make 10 crepes using 1 egg. How many crepes you can make depend on how many eggs you have in your house. So 10 crepes for 1 egg. How many eggs will be needed for 50 crepes? Well, I have 10 crepes, use 1 egg. $50 crepes will be how many eggs? Let's take a look. 10 times what is 50? 10 times 5 is 50. So then I just do 1 times 5 is 5. So we're going to need 5 eggs if we want to make 50 crepes. You're going to answer the following reflection question and be ready to share your response tomorrow in class. So make sure you write this out. Focus question. What is a constant of proportionality? What does the constant of proportionality tell you? Take a little time to write that up tonight. Bring it to class. Be ready to share. Have a good night. Thanks.